there. Welcome everybody who popped in while I was getting stuff ready. Welcome everybody. We'll get started here in just a second. Welcome. It's nice to see your white font on black backgrounds. Right. I think we have just about everybody, so we'll go ahead and get started. If anybody joins us, like now, I'll be sure to let them in. Good morning and welcome. I'm glad you're here. Our plan, as more people join us. Whoops, sorry. We want to do our check-in, but this time I want to try to be responsive to the survey that you completed the other day around your mindful awareness, how aware you are of the present moment and what you're feeling and what you're thinking, and then see if we can actually do some work around that that might increase that a bit. And I want to share the results of the survey with you as well. There's pretty much an overwhelming request the other day to do one more chi-square practice problem. So I've got a problem that we can do together. I hope that will be helpful. We'll take a break about at the halfway point or close to it as we can get. And then we're going to come back and begin to look at an interaction between two species, our first interspecies interaction, and how that interspecies interaction has been influenced by natural selection over the course of time. Up until this point, we've been focusing on, except maybe for lab number 6, a single animal or a single plant behavior and how natural selection may have favored or disfavored that particular behavior or characteristic over the course of time. This is the next logical step to look at how, if you have two different species and they're interacting in some meaningful way, how might natural selection have influenced the interaction over the course of time? So we'll do some independent work around a real life example of some different interactions between pollinators and a flowering plant. Okay, and of course we'll end with our exit slip before we call it a day. All right. So before we get started, is there anything that I can do for you to make your lives a little bit easier or a little bit happier this morning? well, my hope is that if there's anything that I can do, you'll let me know, chat, remind, text, email, take yourself off mute, dare I say. Um, well, if you had a chance to complete that survey at the beginning of class on Monday, about 80% of people did. That was pretty awesome. These are the results, not just from your class, but from all 4 classes, all 4 sections of AP Biology. If you don't remember the questions or if you didn't do the survey, I would encourage you to take a look at the legend. That's where the questions are listed. And take a look at the magnitude of the bars. These are the average scores for each of those 5 questions. And dare I say, the stuff that I teach you is stuff that I actually use. So there are error bars. They are 95% confidence intervals in this case, because I was looking to see if there were any significant differences between the way that you answered these questions. And I think overwhelmingly, we can see that there are some differences. Specifically, right there. And it's been a couple days, and I wouldn't expect you to remember, but lower scores actually are representative of a less mindful state. And all that really means is that you're less likely, especially in the context of this question, to be present in the current moment. And that means you're human. We spend a lot of time thinking about what has happened to us, and we spend a lot of time worrying about what might happen to us in the future. But when we really pause and take a moment to think, we have absolutely no control over the past nor the future. So what I'd like to do with you, just for these next couple of minutes, is see if we can work with some present moment awareness, building that skill. It's hard. And for some of you, it might feel weird. And I'll say up front, you don't have to do this. It's an invitation. Okay. So if you're interested in heightening your present moment awareness a bit this morning, I would invite you, wherever you are right now, to just make yourself comfortable. Find a position where you're upright but relaxed, comfortable but confident. Maybe just take a deep breath in. And as you breathe out, just allow yourself to kind of sink into your seat a bit. Let go. Maybe notice how your body is connected to your seat right now. Maybe even notice your feet on the floor. Where are your hands? What I would invite you to try, if you're interested this morning, is to start at the top of your head and just scan from the top of your head down to the bottoms of your feet. And first, as you scan, try to notice if there's any spot in your body, any place in your body where you're feeling something pleasant. It could be warmth, sense of relaxation. It could actually be nothing at all, but it still feels pleasant. Just make a note. Where is that in your body right now? Where are you experiencing something pleasant? And then I would invite you to repeat that same process, scanning your body from top to bottom. But this time, rather than trying to notice something pleasant, see if you can notice something unpleasant. Maybe it's tension, soreness, pain. Maybe it's nothing at all, but it still feels unpleasant. And make a note of wherever that resides in your body right now. So, with those two sensations in mind, what I would invite you to do next is to come back to your device and drag two different dots. There's a green dot, and with the green dot, I'd like you to drag the dot to the spot of the body silhouette, right, to the human body where you experience that pleasant sensation, wherever it is, whatever it was. And with the red triangle with the exclamation point in it, drag that dot to the spot of the body where you experienced something unpleasant, whatever it was, wherever it was. Just take a look at what people have done so far. Looking for patterns, trends. Lots of dots are moving around. We don't know who's who, and that doesn't really matter right now. We're just looking for patterns. Definitely seeing some clusters of green around the face, the neck, the chest. Also seeing a lot of red triangles, kind of a little bit lower. Heart, belly, pelvis, head. So with this in mind, wherever you've dragged your dots, what we've done so far is notice. And how often do we actually take the time to do this? Our lives are go, 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 go. Homework, class, friends, phones, life. But after you notice it, can you name it? So of these two sensations, pleasant and unpleasant, was there one that was stronger than the other? If not, that's okay. They could be the same. But after we notice, we want to try to name it. And what you're looking at are actual heat maps that human beings created for where they experience different emotions inside of their bodies. And I would invite you to do something similar, to drag the dot to the body and thus to the emotion that you just experienced more strongly in this moment. Give it a name. whatever you experience more strongly, pleasant or unpleasant, it doesn't matter. Is there a part of this image that matches what you just experienced? Can you drag your dot to that person, to that silhouette, to that part of the body, and give what you experienced a name? There's a trend emerging, right? And it's not the same for everybody, and it doesn't have to be. Anxiety. Heck, maybe the act of looking inward created that sense of anxiety. That's totally possible. It's also okay. It's scary to look inward sometimes. But you've noticed, you've named, and I would invite you to do one more thing, and we're not actually going to have time to do this right now, but maybe during our break today, you have to try to stay in the present moment just a little bit longer. Got very short guided meditations that you might want to take a look at, that you might want to listen to during our break today, but maybe not during the break. Maybe you need to go to the bathroom during the break, and you're going to do this later on today, maybe before you go to bed. It doesn't matter. And you don't have to use these, you can use anything. But to take a moment to bring a sense of awareness to what's happening inside of you right now. To notice it, maybe to name it, and then be kind to yourself with the understanding that whatever it is that you're experiencing is not permanent. It could get bigger, but it could also get smaller. It might change into something totally different. But in that moment, you will have been living in the present rather than in the past or in the future. So, I'm curious, what do you think? Useful? Not useful? Not really sure? Need to do some more work around this? It's okay to say no. Where's the biology? Let's get to the biology. What about the content? What about the test? It's future. You have no control over that. I can't do this every day, of course, but I wanted to be responsive to what I saw come out of the survey. And I wanted to just share something very simple with you that you can do at any moment of the day. Notice, name, be kind. And maybe play around with it today, tomorrow, this week. See what happens. See what happens. I think you might be surprised. Alrighty. Well, if it's okay to transition, I want to honor the request for some additional chi-square problems. And I think overwhelmingly what I saw was that people wanted me to lead one more problem or one more solution to a problem. And I thought long and hard about the different problems, and I thought, well, let's just make up one that no one's had a chance to look at yet and work through that one together. And I thought the best place to do that would be to go back to that koi fish pond in lab number 5 with the Hardy-Weinberg equilibrium. But if I remember correctly, when we did a practice problem with the koi fish pond the first time around, we did it under the default conditions. So we had our initial conditions that were just kind of set up by the simulation, and we used those allele frequencies and genotype frequencies to do some calculations, and then we let it run for 50 generations, and we got our new allele frequencies and our new genotype frequencies, and we asked a really simple question, right? Under those default conditions, had the population changed, right? Had it evolved? Quantitatively, mathematically, in a statistically significant manner. And I think, if I remember correctly, for this class, we found that, maybe not surprisingly, it hadn't changed. Right? We had to accept the null hypothesis that there was not a significant difference between what we observed after 50 generations and what we would have expected to have taken place if there was no change away from those default baseline conditions. So the new problem is to do kind of the opposite of that, to actually change a variable in such a way where we would expect there to be a statistically significant change away from those baseline conditions, so as to not support the null hypothesis that there is not a difference, but instead to reject that null hypothesis, and as a consequence, accept the alternative hypothesis that there is a difference. Okay. So what I did, just to save a little bit of time, was I went back to the simulation and I recorded a new set of default conditions. Every time you open it, you get slightly different values. So those are the values up top in yellow. I hope you can see them on your end. Okay. And then the variable that I chose was to alter the relative fitness of the homozygous dominant individuals. So I lowered that value to 0.5, which in essence means that I'm selecting against any individual that has that genotype in the population. I'm making it harder for them to survive and or to reproduce. The homozygous recessive individuals and the heterozygous individuals, they weren't impacted. I didn't change their values at all. 1 is the default. Okay. So I ran the simulation for 50 generations. I recorded the allele frequencies, well, I guess the genotype frequencies in this case, in green. Quick aside, I noticed that my population size changed a little bit. That's going to be important for us because we're going to have to account for that new population size in our calculations. But those are the observed values. I know my genotype frequencies. They're coming out of the simulation after 50 generations. And if I multiply the genotype frequency by the size of the population, again, which is 187 rather than 200, I'm going to be able to calculate the number of individuals with each genotype in the population after natural selection had its influence over the course of 50 generations of time. Okay. So just pausing there for a second. Is that bringing any questions up in your minds? Anything at all? I try to monitor the chat and your white names on black backgrounds. Okay. So really the hardest part of a chi-square problem is not the observed values. Oftentimes they're either given to you or you're going to be able to calculate them very easily like we just did. It's finding the expected values. Well, the expected values are ultimately derived, from the null hypothesis, right? In this case, okay, great. Well, if I would have expected there to not have been a change, then what are those values going to be if no change actually took place? Okay. So to do that, pulling up my pen here, I'm going to have to work with that population size of 187. Okay, I can't use the 200. It's not going to work in this case. Otherwise, I'd be comparing apples to kumquats. Got to keep my population size the same. Okay. But 187 times the expected frequency of homozygous recessive individuals if the population didn't change is 0.23. And then similarly, for the heterozygous individuals, I've got a frequency of 0.57. Please excuse my penmanship. And then for the homozygous dominant individuals, I'm at 0.2. Again, I'm using the default conditions as my baseline, right, to ultimately test the null hypothesis. Is there a significant difference, or really is there not a significant difference between what I observed after 50 generations compared to what I started with? Okay, so I do my math. I've got 43 here, and 187 times 0.4, so that's 107. And 187 times 0.2 is 37. I'm rounding. But ideally, that should sum to my 187, and I believe that it does. Whoops. Sure does. Okay. Once I have those values, the math is going to be simple. Let's see, that's 16. Oh, I've got my $700 calculator here, right? I might as well use it to my advantage. 73 negative 38. Negative values don't matter because we're going to square. Oh, and that one's simple. That's negative 35. Maybe you're already seeing what I'm seeing. You're going to end up with gigantic values here, which I guess you could argue is a good thing, given what we did in the simulation. And then we're going to go back and divide by our expected values. Again, these are going to produce really large values. And 33 and some change. But we can see really clearly our chi-square value is big, right? Chi-square is 170.6. Okay. Well, that's great. We have our calculated value, but just like with the correlation coefficient, we're not done. We need to compare the calculated value to a critical value. All right. So just like with the correlation coefficient, the table of critical values will be given to you. You never have to memorize it. Apologize for the ink all over the screen, but in an investigation like this, and an analysis like this, with fingers, how many degrees of freedom am I working with? And if you can't put your fingers up, you can just put a number in the chat real quick. How many degrees of freedom am I working with in this analysis? Thank you, Paige. Thank you, Max. If you don't remember how to calculate the degrees of freedom, it is at the bottom of the screen. It also will always be given to you. You never have to memorize it. So I'm seeing quite a few 4s pop up. How many categories, how many groups, how many genotypes are we working with in this problem? 3. So there's 3 categories worth of data that's coming from our experiment. For the degrees of freedom, it's the number of categories or groups, if you prefer, minus 1. So there are 2 degrees of freedom in this analysis. Okay. So with 2 degrees of freedom, it's always going to be safe to use our 5% probability due to chance value, our alpha value, if you remember from the reading last week, that the outcome of this experiment is actually due to chance, but in biology, that chance is often thought of as the result of naturally occurring variation within the population, right? And using a 5% threshold is always a safe place. If we want to be more stringent, we can, but we don't have to be. But our critical value at a 5% probability due to chance and 2 degrees of freedom is 5.99. So my goodness gracious, 170.6 is far greater than 5.99. That null hypothesis is toast. Throw it out. It's disproven. You have to accept the alternative hypothesis, which probably isn't that surprising to you. we let natural selection run its course for 50 generations, right? Of course, there's going to be an impact. But the bigger question is not whether or not there's an impact, but is that impact statistically significant? And obviously, in this case, it is. 170 is greater than 5.99. We can make a claim that natural selection has impacted those homozygous dominant individuals in a way where they were less likely to survive and reproduce and became less common in the population over time. The population changed. All right, so again, a lot of me talking. It's always very awkward talking to myself in a big classroom. Questions, comments, wonderings?
Is the x squared value the same thing as like what r squared would be?
No, this came up in the other class too. So we have to be careful. It's not an X, it's the Greek letter chi. I know it looks like an X, but it's chi. This is a different type of statistical analysis, right? This analysis is using discrete data, data collected at one moment in time, right? The correlation coefficient, R squared, right? That's being used to analyze data that's been collected over the course of time. So it's continuous data. You know, think of lab number 6 where you watch the bee leave the hive and visit different flowers and then come back, right? That was taking place over the course of time. So it's a very different type of data, and as a consequence, the data needs to be analyzed differently. Okay, so the chi-square test is for discrete, categorical data collected at one moment in time, tests like the chi-square test. Sorry, tests like the correlation coefficient, the Pearson test. They're being used for data collected over the course of time. And this is what biologists do, right? They have to choose the right test to analyze their data for statistical significance. And no one tells them what to do or how to do it. They have to figure it out for themselves. And if they can't, they ask for help. Anything else?
You always use the like 5% one.
I'll be honest, Ozzy, it will depend on the question. So usually the College Board is going to ask for the 5% probability due to chance. They'll make that very clear. If not, they'll say, okay, we want you to use the 1%, the 0.01 value instead. You won't have to guess. All right. But if you find yourself, well, what value do I use? Go ahead and use the 0.05 value. You're always safe there. Is it okay if I erase this? Well, this seems like a good spot to take our break. It's 10:31, so we'll do our normal 3 minutes and we'll come back together at 10:34. I will put the slides in student mode just in case during the break you want to go back and try one of those short guided meditations. Otherwise, I'll just see you in a few minutes. we start making our way back together. Alrighty. If anybody tried any of those guided meditations, I'd love to know about it. You could send me a private message if that's something you tried. You don't have to, of course. But what I mentioned at the beginning of class, right, is what we want to do next is look at how an interaction between species can actually be influenced by natural selection over the course of time. So you may have noticed that this unit has the word ecology in it, right? So we started with behavioral ecology, and now we're looking at community ecology. So this is really our first attempt at studying the community aspect of ecology, how different species are interacting with each other, but how that interaction can actually be influenced by natural selection is an important point to consider as well. So to introduce us to what we're going to do next, if you'll take a moment just to read what you see on the screen, those few short paragraphs. And when you're done, just a thumbs up to let me know that it's okay to move forward. Thank you. All right. So the image on the next slide really just is a visual representation of what you just read, but to take a moment just to kind of scan, it goes from top to bottom and then right top to bottom. And again, thumbs up when you're ready to move forward. Is anything that you've read or looked at so far bring any questions up in your minds? Okay. My hope is that you're seeing the interaction between the species, pollinator and flowering plant. All right. So what we're going to do for these next few minutes of class is do some work independently on an interaction, not surprisingly, between a pollinator and a flowering plant. One of the pollinators is the good old bumblebee. The other pollinator is a hoverfly. When you think of the word hoverfly, what will probably come to mind is just a simple housefly. They look pretty similar to a housefly. And everything that you're going to be working on for these next 10, 15 minutes of class is coming from a scientific paper published just a few years ago. So these are actual data collected and published by scientists that I want to give you a chance to first analyze on your own. And we get together again on Friday to talk about in a small group so as to develop a deeper understanding of what's happening. So if you'd like to read the abstract from this paper, I put it up on this slide, but much of what's in this abstract, and if you're not sure what an abstract is, it's just a brief paragraph summary of what a scientific paper is all about. you're welcome to come back and take a look at this. But again, it's much of what you've already read and looked at on the previous slides. Okay, so you are a period 6 person. So my hope is you can see the sheet. I need to scroll down a little bit. You will find your name and the number that matches your name. Sorry, you're at the bottom of the alphabet. My screen is not quite big enough, but maybe your screen isn't big enough either. Everybody have their number? Thumbs up if you've got your number, or a head nod is okay if you're on camera. Yes, Jesse. In fact, the flowers can rely on other pollinators. The question becomes, is natural selection going to influence an interaction over one pollinator compared to another? All right, so if you've got your number, close out of this here real quick. What I have created, oops, are 5 different slides, right? And so the slide number on the bottom right matches your group number that you just took away from the spreadsheet. So what I'm going to encourage you to do is find your slide. I'll give you control over the slides here in just a second. You want to read the intro up top just to kind of familiarize yourself with the experiment, and then look at the graph. There is a short graph summary, figure summary at the bottom of the slide. And then there are 3 questions that go along with every one of these slides, every one of these graphs. On the next slide, again, you'll have control over these. There's a spot for you to begin recording your thoughts or even your answers to these 3 questions, okay? So that is your task independently for these next 10 or 12 minutes of class, okay? Is to read the scenario that's been assigned to you and then try to answer those 3 questions on the next slide. If you have clarifying questions or things you're not sure about, that's why I'm here. I want to provide you with some time to ask those questions either out loud or in the chat, whatever works best for you as you're working, okay? So before we get started and I give you control over the slides, what questions do you have for me? Okay. Well then, you've got your number, find your slide, take a moment to read and make sense of it. When you're ready, you can start answering the question on the next slide, and I'm here to support you while you're doing this. This is tough stuff, what you're about to do. In many ways, this is your first attempt at looking at the data that comes directly out of a scientific paper published by adult scientists just a few short years ago. So if you struggle, it's okay. Ask for help. Sorry, she's in the restroom. Moving my body a bit. I will say the Googling step is not necessary. You get everything that you need from the information provided. Forgot how much I love figure 5. Everything you write will be saved for next time. So even if you just find yourself capturing a thought or a question. Yes, some people are doing some graphical analysis, some error bar analysis. That's wonderful. That is part of this process, right? If there's a difference, how do you know? So if there's an effect of one pollinator on another, sorry, if there's an effect of one pollinator compared to another, how do you know? Yeah, this is great stuff. If you find yourself struggling, don't sit there in silence. It's okay to reach out. Yeah. Lots of good thinking so far. Thank you for those who have already begun to fill out those slides. Take another minute to wrap up what it is that you're doing with the understanding that you'll have a chance to come back to this next time. All of your work will be saved. All right, I'm gonna take you out of student mode just for this last minute. So I'm never sure if you get a chance to look at the learning objectives on the bottom of of our agenda slide every day. So I rewrote it here. But what we're beginning to look at is how communities, so multiple species of living things, right? Multiple species are interacting, and how those interactions lead to change within the system. Okay. So if you could, before you go, really focusing on what you just did for these last 15 minutes of class, how does that experience help you understand this objective a little bit more? You could just type your response in to the box, and as soon as you've finished, this is your exit slip. You're welcome to sign off. We will continue this experience of the deep data dive in the interactions between species more on Friday. And there's a lot of communication taking place that we are unaware of as human beings, isn't there? Yeah. It does apply to everything.
Thanks, Mr. Bergeron.
You're welcome. It's been a couple days.
Thank you.
Thank you.